Hello, grade 12 learners, and welcome to today's Life Sciences lesson. In this video, we are going to explore the third topic of the matric curriculum, reproduction in invertebrates in detail. A firm understanding will help you both in your exams and in building a clear picture of how the human body works. Reproduction is the process by which living organisms produce new individuals, and it is very important because it ensures that a species continues to exist and does not become extinct. In invertebrates, there are different reproductive strategies, which are structural, functional, and behavioral adaptations that increase the chances of fertilization and survival of the offspring. These strategies can differ in several ways, such as the number of eggs produced, whether fertilization occurs inside or outside the female's body, whether reproduction is sexual or asexual, where the embryo develops and gets its nourishment, how quickly the young become independent, and the amount of parental care provided by the parents. The two types of fertilization are external and internal fertilization. In external fertilization, which is common in many aquatic invertebrates such as annelids and echinoderms, fertilization happens outside the female's body, usually in water. Both eggs and sperm are released into the water, and because many of these gametes may not survive, large numbers of eggs are produced to ensure that at least some will hatch. However, mortality is very high because the eggs have little to no protection, they can easily dry out, and they are easy targets for predators. In internal fertilization, which occurs in many terrestrial invertebrates such as insects and some mollusks, sperm is released directly into the female's body, and fertilization takes place inside. This requires fewer gametes because survival chances are much higher. The developing embryo is protected inside the mother's body or inside a protective egg case or cocoon. Invertebrates also reproduce asexually in some groups, which allows a single individual to produce offspring without a mate. Examples include budding in hydra, binary fission in protozoans, and fragmentation and regeneration in flatworms and starfish. Asexual reproduction produces many identical offspring quickly, which is useful in stable environments, but it does not increase genetic variation. There are also different modes of reproduction in invertebrates. In ovipary, the female lays eggs and the embryos develop outside her body. Nutrition comes from the yolk stored in the egg, which may be protected by jelly-like layers, as in many aquatic invertebrates, or hard coverings, as in some insects. In ovovivipary, fertilization is internal, and the eggs remain inside the female until they hatch. The embryos are still nourished by the yolk in the egg rather than the mother, but staying inside the body gives them some extra protection until they are ready to survive on their own. In vivipary, which is less common in invertebrates but seen in some scorpions and insects, fertilization is internal and the embryo develops inside the female's body, receiving direct nourishment. This provides a higher level of protection and survival for the developing young. The way the young develop can also differ. In precocial development, the young are well developed when they hatch or are born. For example, many insects hatch into active larvae that can feed and move on their own. In altricial development, the young are underdeveloped when they hatch and need more parental protection, such as in some social insects where larvae are fed and cared for by worker ants, bees, or termites. Finally, parental care is another reproductive strategy that plays a big role in the survival of offspring. In most invertebrates, there is little to no parental care, and survival depends on producing a large number of offspring. However, in some groups like social insects, parental care is highly developed. Workers protect and feed the young, defend the nest, and ensure the survival of the colony. An important adaptation in many vertebrates is the amniotic egg, which has extra embryonic membranes that support development. The amnion produces amniotic fluid that cushions the embryo, protecting it from mechanical injury, temperature changes, and dehydration. The allantois stores nitrogenous waste produced by the embryo and helps with gas exchange. The chorion allows gaseous exchange in the egg, and in mammals it goes on to form part of the placenta. The yolk sac stores food for the developing embryo. The size of the yolk also affects development. A smaller yolk means the embryo hatches sooner, but is underdeveloped and needs more parental care, while a larger yolk means the embryo takes longer to hatch but is more developed and independent. In summary, Invertebrates use a variety of reproductive strategies: sexual and asexual reproduction, external versus internal fertilization, ovipary, ovovivipary, vivipary, precocial versus altricial development, and different levels of parental care, all of which are designed to ensure the survival of the next generation. If you guys would be interested in purchasing my handwritten notes, they are very colorful, helpful, and in good detail. Please let me know in the comments. And that brings us to the end of today's deep dive into reproduction in invertebrates. Make sure to revise the diagrams of invertebrate reproductive methods, as labeled drawings are a frequent feature in your matric exams. Thank you for listening, and keep working consistently. Small steps every day build up to exam success. Until next time, happy studying. Good luck with your exams. You've got this. God's got you.